everyone, I'm Nurul Hazrina binti Nordin from UMPSA STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Welcome to Micro-Credential 3 Raspberry Pi Programming, the final module in our structured learning series. In this course, we will integrate Python programming with hardware, utilizing Raspberry Pi systems and microcontrollers like the Raspberry Pi Pico to develop innovative real-world applications. This course builds upon the foundation laid in Micro-Credential number 1, Learning Python through Slider Game Development, where students mastered programming fundamentals, Micro-Credential number 2, Raspberry Pi Installation and Configuration, where students learn to set up and configure for Raspberry Pi for hardware interaction, and Micro-Credential number 3, Raspberry Pi Programming, which is this course. We will write Python programs to interface with hardware components. And Micro-Credential 3, Raspberry Pi Programming, this course, where we will write Python programs to interface with hardware components. So this course basically is designed to bridge the gap between software and hardware, covering essential topics such as Chapter 1, Introduction to Raspberry Pi. Here, you will understand the capabilities of Raspberry Pi for hardware-based programming. Chapter number 2, Control Flow. Here, you will learn about loops, conditionals, and functionals to control hardware interaction. Chapter number 3, Working with External Libraries. Here, you will explore third-party Python libraries to enhance Raspberry Pi functionality. Chapter number 4, Interfacing with Sensors. You will learn to connect and control sensors and actuators using GPIO pins and Python. And finally, chapter number 5, where you will learn about cloud integration, networking, and communication. Here, you will do activities that will send and receive data via the cloud, enabling IoT applications. A major project in this course will involve coding for UMPSA STEMcube, a Pico satellite simulation, where students will implement data collection and processing technique using Python. This will give students hands-on experience with real-world embedded system and IoT application. Micro-Credential course number 3 is Raspberry Pi Programming. In this course, we will explore how to program and interface with the Raspberry Pi Pico and Raspberry Pi 4 to develop real-world applications. Throughout the lessons, we will cover essential programming concepts, external hardware integration, sensor communication, and wireless networking. Whether you are a beginner or looking to enhance your skills, this course will provide hands-on experience in embedded programming and IoT applications. This course is structured into 5 key sub-chapters, each building upon previous one to give you a solid foundation in Raspberry Pi programming. So let's go over each and every sub-chapters briefly. In this chapter, we will introduce the Raspberry Pi Pico, its features, and how to set up programming environment. You will learn how to write your first Python script and run it on the Pico. Next, we will move on into control flow in Raspberry Pi. Here, we will dive into control flow concepts using digital input and outputs. You will learn about sequential executions, conditional statements, and loops by controlling LEDs and responding to button presses. This will help you to understand how programs make real-world decisions. Next, we will look into working with external libraries. Here, we will focus on using external Python libraries to work with additional hardware. We will install and utilize libraries to interface with OLED display, allowing us to display text and graphics using Python. By the end of this chapter, you will be able to integrate and use third-party modules effectively in your projects. Next, we will look into interfacing with sensors. Here, we will explore sensors communication using various protocols such as I2C, SPI, and UART. You will learn how to connect an accelerometer to your Raspberry Pi Pico, real-time motion data, and process sensor values in Python. This knowledge is essential for building interactive projects like motion control devices. And finally, we will look into long-range wireless communication using LoRaWAN and MQTT. You will learn how to send and receive data wirelessly using LoRa module, making it possible to create IoT applications for remote monitoring and control. We will also discuss power-efficient communication methods for real-world deployments.